Hello. Hello. Hope I'm audible. I'll start in a few minutes, okay? I'll start exactly at 7 o'clock. Hello. Hello. Okay. Please wait. I am waiting for others to join. We'll start exactly at 7 o'clock, okay? So if you have any doubt, you can ask. Someone joined. I Let me check the name maybe. Okay. I think Nitish. If you have any doubt, you can ask. Otherwise, we will wait for others to join. Okay. To start week 2 tutorial session.
Well, only elaborate for limit in details.
Sorry. Can you
Some,
can you can you speak again?
sir, I want to please highlight some topics related to limits, sir.
Okay, okay. So we'll have some questions related to those only. Epsilon delta, mostly epsilon delta definition, right? That. your meaning, I think,
Thank you, sir.
right?
Okay, sir.
Yeah, that we will discuss first about limit. See, like this type of questions are there, like 1 by x, how it is converging to 1 by c, let's say c greater than 0. Right? I mean, if you do simple questions, even you will understand that how why it is, like how the limit definition comes. So I'll go through the examples. If still you are not understanding, then I'll discuss it. Like we can discuss one by one also. That is not a problem later. Okay. You as I have the examples here, so that's why we will first discuss the example. I hope through example also you can understand. Hmm? So if not, then we can discuss one by one, right? So otherwise, if not people are joined, so mainly you have, okay. I don't know why it is doing this. Maybe let it be. So you have limit as x tends to a, fx is equal to L, right? So you mean what is the meaning of this, right? Or what?
Yes, sir. As
Yes. So if you have function, let's say this is fx, and you have a, this is the x axis. This is x, then it will be fx, corresponding fx this. And here is a point A, right? So when x approaching to A, is the meaning is A can approach from this side or this side. It can approach from this side or it can approach from this side, right? So when x approaches to A, fx should approach a number. In this case, maybe this one, let's say L. So if fx approaches, that is first thing. If, as x approaches to A, fx should approach to L. Hmm? So what is the meaning of that? So first is this implies this. Hmm? So second is, what is the meaning of this? As x tends to A, fx tends to L. So if you start with any like fx minus L, this mod less than epsilon. What is the meaning of that? Fx lies in L plus epsilon to L minus epsilon. So what is L? You had L here, so you take L plus epsilon and you have L minus epsilon. So this is corresponding L, you have L, and this is L minus epsilon, this will be L plus epsilon, L minus epsilon, L plus epsilon. So what you are telling, for all such epsilon, for all epsilon, you will find a delta such that this fx will lie in this interval when x is in that a plus delta to a minus delta. So there will be a neighborhood a minus delta, and here will be a plus delta. So whatever epsilon you give, no matter how small that is, so in the neighborhood of L, fx will always be there as long as you have a neighborhood around A. So that means it is approaching to L, right? Mainly whatever epsilon, it can be 1 10 to the power minus 10, 10 to the power minus 100, epsilon can be very small. So what is the meaning of that? Means the value is getting closer and closer to L, and fx values are very closer to L whenever x is in the neighborhood of A. That A neighborhood A is a fixed number. So in a, so this type of things, that this is limit idea mainly. So that is how epsilon delta definition comes. So you have to have this limit, and neighborhood of that limit L minus epsilon to L plus epsilon to L minus epsilon. In this neighborhood fx will lie, imply sorry, it will be high, yeah, it will be L minus epsilon to L plus epsilon, meaning that fx is closer to L whenever, whatever, if you take very small L, that is the meaning of fx is closer to L, right? That's what we I did in the first class, I think, fx minus L to real number, and that is less than epsilon for all epsilon, that implies fx equal to L, that type of things. Here it will be depending on x, so it will be also x dependency is there, x belongs to your a minus delta to a plus delta. So it is a meaning that fx is getting closer to L whenever x is getting closer to delta, sorry, a, right? So that's how mathematically precisely it is given. Otherwise, the idea is x approaches to a implies fx approaches to L. You have any like uh, doubt, specific doubt, or I mean, I don't understand whether you are getting it. We'll do it with some examples. Okay, right, Nitish?
Okay, sir.
Okay. Yeah. So okay, we did for everyone. We did not start it yet, so we'll now start with our tutorial of week 2. Welcome everyone. This is Rahuldev Ghorai from ISO Thiruvananthapuram. This is your second class, and this is yeah, of lecture 6 to 10. When we have limit of functions, what we have, you must have seen, and then have continuous functions. Like for continuous function, that limit L should be f of f at a. Okay, anyone asking question, you can turn on your microphone and you can ask. Okay, I have to.
Sir, last week we did like Archimedean property and problems regarding that, right?
Sorry. Yes, tell
Uh,
please.
Sir, can you hear me?
Yeah, I can hear you. I can hear you.
Last week we did like proper problems regarding like Archimedean property and then limits, right?
No, limit was like, I think I did not do limit much. That's why I kept it also. And limit was part 1 and part 2 of lecture. That's why. Yeah, tell.
Yeah, so, sir. So you gave some notes for that, right? Should we email you for those notes, or have you shared?
No. Okay. Sorry. I forgot to upload it in the Google Drive. You
Uh,
have some Google Drive access, right?
Google Drive?
Yeah, we share some good not yeah, Google Drive access. My Google Drive mean you have some this lecture notes will be uploaded in that Google Drive. You
Okay.
ask your friends maybe. You see, you check from where the this videos. There will be this Google set something.
Oh, okay,
Sorry,
sir.
Google Drive link, not Google Sheet, Google Drive link.
Oh, in Swayam portal itself, it's there.
Siam portal, yeah, it must be there in the, like, you have a link for videos, and there you have, I put usually the Google Drive link also. I don't know how you get. You ask your, anyone knows, you can you tell him? Anyone, other people are here? Only 2 people. Uh, may I ask Nitish? Maybe Nitish, can you help in this regard? Him to tell him.
As in, sir, when we open swim portal, then in navigation bar, when means left side at bottom, all the features are shown, sir.
Okay. Yeah, it
In
tell.
problem solving session reminders, sir. When we open this, then all the details will be open, sir.
Oh, okay.
Sir,
Yeah,
is that
we,
problem solving session?
yes, inside
When
problems.
in during login, sir,
Sorry.
and Google Sheet open, sir.
Google Sheet, and there you have all these things, right?
Yes, sir.
Yeah. You tell. Understand?
Yes, sir. Yes, sir. Understood.
Yeah, I have, but I haven't uploaded there. I'll upload. I forgot. I'll upload to both these. Huh?
Ah, okay.
Yeah. Any doubt from there or like you? No.
No,
You
sir.
will.
I just wanted to like complete the week one assignment, so I just wanted to go through the notes once and then do it. That's all.
Okay, no problem, no problem. Yeah, I'll put that thing, and you will
Deadline
have.
is there, sir. Deadline is there. 4 more days are there, so no worries.
Okay. Deadlines. Yeah. I today itself I'll do that. Huh? If otherwise you have to remind. Okay, I'll do that. I'll try to do that. Hopefully, I will not forget. Okay, thank you for reminding. I'll just do that. Okay, so come back
Sir,
to the yes. Tell, please.
sir, as I my first today is my first class, and some reasons I couldn't join your previous class. So can you elaborate some topics related for your previous class, sir? So I'm not I am
So
worrying.
see, yeah. What is the Nitish, right? You are.
Yes, sir.
See, I will upload. I have uploaded the videos. Did you check that? No, right?
Okay, sir. Means
Videos are recorded and uploaded. See, for the thing is, you check the video and notes are also there. One after that, if you have doubt, I can of course surely assist you. But before that, you should go through the videos once. Just maybe by putting speed, maybe some like 2 times speed or something. You do that because it's a long video, right? So somehow you just try to finish, try to understand what he said there. Then, if you are not understanding some part or something, then I can tell you. No?
sir, there will be only one live session with you, sir.
No, two live sessions are there with the two tutors. Okay. Another one I think will be on Tuesday, if I am not wrong. You just check it. But
Okay, okay,
yeah. Hmm.
okay, sir. Sir, proceed, sir.
Yeah.
Thank you, sir.
Yes. But you go through once, if you then I can tell you rigorously. These problem solving sessions should be useful for everyone. Like this, you should try to solve by yourself also, and then you ask whatever doubt you have. I think this is a very good uh, thing. Like you have a good opportunity here, right? So you can ask face to face, and you can do solve problem in this class itself, and you try to do. And these are the problems which will be very important. And like at least I feel. So you can have some ideas of limit, ideas of continuity, and intermediate health. The more you solve the problem, you understand better, I guess. Okay, and so yeah, limit, continuity, like you have the theory and the intermediate value theorem, which is like says that if f is a continuous function on a closed interval a to b, and if a is less than c less than fb, then you will have a point fx so that fx will be equal to c. So that is intermediate value theorem. So I will be assuming all these things and then I am moving, because otherwise I cannot solve many problem. And you have maximum principle. I don't know whether it is done. So if it's I will not be doing in this class, because yeah, so leave this maximum principle. But supremum infimum, then you have supremum infimum is supremum of a, and so supremum of a is the least upper bound, and so infimum of a is the greatest lower bound. So assuming all these things, all of you knows, I am just moving. Okay, any doubt here? If you specific doubt you ask, I'll then tell little bit, and then I'll move to the problems solving session, like questions only. Questions mainly related to the assignment, related to like for your better learning. So all these things, thinking about all this thing, I made the questions, and we'll be solving those questions. So before that, if you have any doubt, please ask. Theory, everyone clear with the theories for theory part? Okay, so assuming that, let's move to this one. It's a very simple one, like 1 by x, limit x tends to c. C is a positive number. You know how this, sorry. Some problem with this. Okay, I came. I don't know what is happening. Yeah. So you know what is, how does this 1 by x looks like this, right? 1 by x function. So if as x tends to c, let's say x is 1, it will be 1. If x is half, this will be 2. And if x is 2, or let's say 3, it will be 1 by 3. I mean, it is very easy to observe that as x tends to, the function is continuous type. Like it's a very, like you don't need to, like you can very smoothly draw this function. And what you see as x tends to half, or half y will tends to 2, or x tends to 3, y will tends to 1 by 3, means, right? Yeah. So what is the meaning of the limit x tends to c 1 by x? That limit should be 1 by c when c is positive. C is when c is 0, you don't have this finite limit. So I am giving fixed that c is strictly greater than 0. But how do you prove that this x tends to c 1 by x is equal to 1 by c using epsilon delta definition? Because see, epsilon delta definition is more generalized one. So to prove anything, limit x tends to c 1 by x equal to c, that is the most precise one. Okay. So maybe for this limit, you can do it much easily. But for other limit, for it will, when difficulty will be there, different type of functions will be there, which not I mean, functions are very hard to solve. I mean, the limit, to get the limit, it will be difficult. For that type of function also you can use epsilon delta definition. Okay, so epsilon delta definition in this case, how we get? So yeah, okay, I have written already the proof maybe here, but I'll first go through it. Okay, I'll first do it here. So you have fx is equal to 1 by x, and you have c as a point. X converges to c implies should be fx converges to 1 by c. That we have to prove. It's not proven. Okay. So how do you start? So for the epsilon delta definition, you start with epsilon is any small number, no matter any positive number, which can be very small. And we start with fx minus 1 by c. Will it be less than epsilon for some x minus c less than delta, right? Whether our aim should be whether x minus c will be less than delta, some delta, for all epsilon. For any epsilon you take delta, that delta might be depend on epsilon, but you can find one delta which depends on epsilon, which is positive. Okay, and that will imply that fx is converging to 1 by c as x is converging to c. Okay, so to do that, what we do here, so I'll start from here. Fx minus 1 by c, fx minus 1 by c is 1 by x minus 1 by c, right? That is less than epsilon, right? Okay, what does that imply? That implies x minus c over x c, that mod is less than epsilon. And what is the meaning of that? X minus c over mod x times mod c less than epsilon, right? Right. So now, okay, that implies x minus c less than mod x mod C epsilon. Now your delta, you cannot choose delta like this because delta will then depend on x. So that we cannot do. So we have to be careful here. So what do we do? You have a point C, right? And you have to take a delta such that for all this C minus delta to C plus delta, for all those x, this will valid be this will be true. Okay, so to do that, let's first assume x minus c is in a neighborhood delta 1, where delta 1 is c by 2 because c is positive, and that is x is less than 3c by 2 greater than c by 2, right? Will come how we are choosing that delta. So when x is in this neighborhood, in the delta 1 neighborhood, x is greater than c by 2. So modulus of x minus c will be less than, if you take modulus of x minus c over 2, that is c square by 2 uh, epsilon, then it will be less than mod x mod c epsilon, right? Because c by 2 is less than x, right? So that is one thing. So what we do it, so delta we choose as minimum of delta by 2, sorry, c square by 2 and c square by 2 epsilon. Okay, and now you see, let's say x minus c is less than delta. What will happen? That implies x minus c less than c square by 2, right? And x minus c less than c square by 2 epsilon. What is the meaning of this? So when you have this x minus c, which is both less than, sorry, not c square by 2, yeah, that is correct now. Okay, so when you have this x minus c is less than c by 2 and x minus c less than c square by 2 epsilon, that implies x minus c less than mod x mod c epsilon, and that implies modulus of 1 by x minus 1 by c less than epsilon, which is nothing but fx minus c 1 by c has to be less than epsilon. So mainly we back calculate, and then what we see that if you have x minus c which is less than delta, and that delta is nothing but c, sorry, c by 2, it will be c by 2, minimum of c by 2 and c square by 2 epsilon mean x minus c also less than c by 2, also c square by 2 times epsilon. Then what will happen, this x minus c will be less than mod x mod c epsilon, because that's why from these two mainly you will get this one, from these two you get this one, and from this two you get this one. So for all x we satisfy this, they will satisfy this, mean whenever for all x such that this happens, then for all fx this will happen. So what's the meaning? So, and you get the delta, that delta is minimum of c by 2 and c square by 2 epsilon. So in general, finding delta is not an easy task, but that is a mathematically precise definition that how you get epsilon delta, right? Do you understand this questions, this answer? Here the explanation also is written here. And that is the question one, like how precisely you prove this limit. This limit extends to c, 1 by x is equal to 1 by c. Why it is so? Any doubt here? If you did not understand at some stage, you just stop me and ask, okay? And otherwise now also you ask. It is little difficult. Is it little difficult? Hello? Are you guys getting this epsilon delta definition? Okay, I will do one more also. See, it's not, these are interesting, say, right? So finding delta, see, for a very simple 1 by x, which you know it behaves like 1 by c when c is positive. Yeah, even if you can prove also for c is positive. So even for that, you see delta is coming like this delta, which depends on epsilon and c points. So these ideas will be later you will understand much better. So whether this c dependency should be there always, or when c dependency is making good problem or not. So in this case, you're fixing c, a point c, and you see the delta which depends on c and epsilon. So that is not a problem at all, right? So you have seen in the books and all, for all epsilon there exists delta, which they did not precisely tell. So delta might depend on epsilon and the point where you are evaluating the limit. So that you should remember. That's the one thing you can take from this example, and you can also do by your, like, as a homework, try to practice and get. You can take another example also, and you find out how to evaluate the delta, how to, what is the exact delta. So see, for all epsilon there is this delta. That delta now you can give. So someone gave you 10 to the power minus 10 epsilon, telling that fx is this much closer. So find the delta neighborhood of x in a neighborhood of c, delta neighborhood of c, such that it holds, that is that much closer. So you can give the delta, like if you have c point also is given, let's say 2, sorry, yeah, let's say 2, then what you have, delta will be minimum of 2 by 2 and 2 square by 2 and 10 to the power minus 10. So it will be 2 times 10 to the power minus 10, right? So when you have delta 10 to the epsilon is 10 to the power minus 10, for c is equal to, you have delta 2 times 10 to the minus 10. So that for all epsilon there exists delta, you can give explicitly. When you have this calculation, when you have done this calculation, you can give this for all epsilon there exists delta, that delta, right? Otherwise you have to just tell, yeah, there exists. No? So yeah, this makes this epsilon delta definition much precise. Okay, so knowing this, now I will do one epsilon delta, using one epsilon delta definition, that this limit does not exist. So you can do it by taking right limit and left limit, right? So that is no problem. You can do it. How? To get a limit as x tends to 0 fx in a real number line, so you should go towards 0 from whatever side you have, you can go, or whatever path you can choose, you can move 0. That should not matter if limit exists. So if limit exists, so that should be equal to limit x tends to 0 plus, and because you have in a real line 0, you can go through here also, you can go through from this side. So whatever side you go, from whatever side you approach, the limit should be same, the value should be same. Fx function should converge to unique number, then only the limit exists. So limit x tends to 0 minus fx, right? Here you see here fx limit as x tends to 0 plus fx. What is that? Limit x tends to 0 plus mean x is positive and approaching towards 0. So whenever fx is positive, you have fx value is 1. So that will be limit will be 1. Similarly, because you see in this interval, the function value is 1, right? And limit x tends to 0 minus fx similarly will be 0. And these two limits are not equal. So limit does not exist. Limit does not exist. But how do you precisely prove? Give epsilon using epsilon delta definition that limit x tends to 0 fx does not exist. How to show that? Any idea here?
Sir, how to select epsilon, sir? Means
No, we don't select epsilon. Yeah, that is wrong. You give epsilon, I will give delta. If I can give you, then that is done. We can show that the limit is there.
according to definition of epsilon delta of a limit, there exists for all epsilon there exists a delta.
Exactly. For all epsilon correspond to one epsilon, give any epsilon, I can give you any delta. I can give you a delta. Do you understand? What is your question? What was your question? Am I overlooking
Sir,
things? Yes, tell.
according to definition, there for all epsilon there exists a delta.
Yes.
For which fx minus mod of x fx minus L is less than exist whenever fx whenever there is a limit as approaches x minus as approaches less than delta.
Yes.
Then what is epsilon mean? I don't understand, sir. What is epsilon, sir? Means how can we define epsilon? What is epsilon?
See, epsilon is greater than 0. It can be
Any positive number, sir?
exactly any positive number. So it can be no matter how much small. Huh? How much small. Any epsilon you give, that's why I started 10 to the power minus 10. Do you understand how small this number 10 to the power minus 10, right? It's very small. For that also I got a delta, which is 2 times 10 to the power minus 10. It can be any different also. It can vary for different point. You take C as very small, you can see maybe or C as very big, then you can see difference. But mostly epsilon, if you take very small, delta, most time you get small, you can get bigger also, depends. Okay. But yeah, given a epsilon, you should find a delta. That is the epsilon delta definition. So that's the thing. Whenever fx approaching to L, you should have x like that should happen when x approach to A. That should happen when x is approaching to A, right? So that epsilon, and for here, that's why I start with, I understand why your question, that's why we start here any epsilon which is greater than 0, and here I gave precise example. So if you can prove that for all epsilon it happens, then you are done. Because you see, we started with any epsilon, we got epsilon and a delta like this. Where I don't know what is epsilon exactly. Epsilon. You give one epsilon, I can give precisely what is the delta. That's the thing. Here also you start with any epsilon, you see that you don't find any delta, such that fx minus L less than epsilon. If you start with this, you don't find any delta such that fx minus x minus c less than delta. So whenever x minus c less than delta, this will happen. There does not exist delta. So that type of thing you have to do here. But how you do this here? It was easy using left limit and right limit, right? So you have any idea, or I will start then?
So, okay, proceed, sir.
Okay, anyone else want to say something? I will do case by case. Okay, first of all, you don't know what is the limit. It's so I let's assume that limit can be, see, most of the time limits are like in this, it is taking only 0 and 1 value, right? It's constant. So first assume that limit is 0. Let's say b is equal to 0, where b is the limit. Okay, instead of writing b equal to 0, let's assume, is this color is okay? I mean, this blue color is visible to you, all of you? Right? Or black colors? What is the x tends to 0? Okay, x tends to 0, fx. Let's say that is 0. This is case 1. Let's do it case by case. It can be, I can take limit as 1 also. I can take any other point also. Why I am taking 0? So that's a case by case. Let's say first assume 0. Let's assume limit x tends to 0 exists and that is equal to 0. If it exists, there should be some finite number, right? Up to this, okay? Okay. And if this is true, then what will happen for all epsilon? We will find some delta. For in this case, let's say epsilon is, I am taking epsilon is 0, less than epsilon, less than 1. Then what will happen? You have this neighborhood of 0, which is 0 minus epsilon to 0 plus epsilon. Okay. In this 0 minus epsilon to 0 plus epsilon, that implies minus epsilon to epsilon. So it is because epsilon is less than 1 does not belongs to minus epsilon to epsilon, right? 1 does not belongs to minus epsilon to epsilon. This much is you okay? Why we started with 0 minus epsilon, 0 plus epsilon? You have this L, when L is the limit, you take L minus epsilon to L plus epsilon, and you see whether fx is there for all x minus delta to x plus delta, right? So start with this 0 minus epsilon to 0 plus epsilon. You see 1 does not belongs to minus epsilon to epsilon. Why? What is 1 value is 1 is here, which is fx is taking value 1 when x is greater than 0, but it can approach to 0, right? So x is approaching 0 means x can be greater than 0, also x is approaching to 0, and that implies x tends to 0 plus mostly. So when x tends to 0 plus, this fx is nothing but 1, but that does not belong to minus epsilon to epsilon. That does not belongs to even x minus epsilon to epsilon. So for all epsilon, you don't have that, means fx minus 1 is even not less than epsilon, because fx minus 1, sorry, not fx minus 1, fx does not belongs to, yeah, fx does not belongs to, fx is greater than epsilon, or fx greater than, yeah, fx is greater than epsilon when x is tends to 0 plus. So you don't have, so if 0 was the limit, you should have x minus fx minus 0 should be less than equal to epsilon, and that epsilon, when you have this epsilon like this, you get fx minus 0 greater than epsilon, or fx when greater than 0, that does not belongs to this epsilon neighborhood, but that should happen for if limit was 0, right? If limit of x tends to 0, limit of fx is 0, then you should have, whenever x tends to 0 plus, or whenever in a very small neighborhood, you should get x minus delta, sorry, not x minus, yeah, 0 minus delta. 0 is the neighbor. 0 minus delta to 0 plus delta when x belongs to this, you should have fx minus 0 should belong, or fx belongs to, here limit is also 0, 0 minus epsilon to 0 plus epsilon. But here that is not happening whenever x is, when x is 0 to 0 plus delta, means you, for any delta 0 to 0 plus delta, what is happening, fx does not belongs to minus epsilon to epsilon. So that is violating the thing that 0 cannot be a limit. Do you understand this much? This is very crucial part, you should understand, otherwise I will tell multiple times, no problem at all, but you should understand this. This is very interesting part, and you, all of you, I want everyone to understand this part, so that you, I think, once you know this, everything else will, you will get it. If needs, I will do it once again, just in a different page. That's not a problem. This is case 1. I assume that the limit of the function is 0. I assume that, and then I saw that it cannot happen. Actually, it cannot happen. If it was 0, then this type of things are happening. If x, when x is greater than 0, mean x is approaching to 0 plus, this fx is not approaching to 0. So, okay, are you talking about this question or before this one also? Someone asked that, yeah, I can repeat. I will repeat, no problem. As I said, I will repeat. But are you talking about this answer or the previous ones or something? No. I don't understand. What is the meaning forms the start, like start mean this start of this question, right? Because I cannot repeat from first, because everyone else are attending, right? I think you are talking about this answer from first, right? When the first question we did also epsilon delta definition, the similar idea, we try to find out delta explicitly. Here we are showing that the delta, that type of delta, does not exist. Is it like that everyone, all of you understood this? No, right? Let's assume no or yes. Someone anyway said that he want to discuss, like he wants once more to tell. See, this is my assumption. So it can be 0, it can be anything else. I am assuming first limit exists. And then if limit exists, it can be 3 cases. It can be 0, it can be 1, it can be any other number also, right? So first start with 0. What is the meaning of this? If this is true, then what would have happened? Fx for all epsilon, this should happen. So whenever, like, you have this fx minus 0 less than epsilon, when x minus c less than delta. What is the exact meaning of this? Try to understand this. So this means 0 minus epsilon to 0 plus epsilon. Means this is a neighborhood of 0. This is a neighborhood of 0. Here c is also 0. So x minus 0. So x will belongs to minus delta to delta. See, this is the precise definition of fx tends to 0 whenever x tends to 0. Right? If this epsilon can be any small, this delta can be also, you can find small or depending on that epsilon. So for mostly, or the meaning of that, fx will approach to 0 whenever x approach to 0. Now, I take, so this should be true. Let's take now, but now let's take epsilon is 0 to 1. So even then also this above thing should be true, right? Okay. So when 0 less than epsilon less than 1, so what happens? F2 to fx. When 0 is less than epsilon less than 1, then what will happen? This minus epsilon to fx does not belongs to minus epsilon to epsilon when x belongs to 0 to delta for all delta greater than 0. Do you understand this line now? Why it is happening? What is the question? Like where you are finding difficult? This next second question. First line is our definition. Second line is the thing we are getting, where we will get contradiction. This is the crucial part. Because why it is happening? When x belongs to 0 to delta, means x is greater than 0, fx is 1. And 1 does not belongs to minus epsilon to epsilon when epsilon is 0 to 1. So that's why fx cannot belongs to minus epsilon to epsilon when x is belongs to 0 to delta. For any delta you have. So you cannot find it. You cannot find any delta so that this fx will be here for all x which belongs to minus delta to delta when it is, because it is not in any delta 0 to delta. Now is it okay? No? I think it was precise, very precise. Okay, I think advaits only, okay, I don't know whether pronounces incorrectly. Other people, please tell. This is the whole picture of your this epsilon delta thing. So for first case, but it will be very interesting. Second case, third, another 2 cases will be there. But is this clear now? Why it is not happening? You understand, more you understand this, you more understand the limit, and yeah, also continuity. Right. Okay, as I said, I can, discuss maybe multiple times, 100 times, and no problem at all. So you can please tell me, okay? I want you people to at least get something out of this. Yeah, so I think as no one is responding, I did twice. So now it is time for me to do the other cases because the no spaces are here. So I'll just read it out here. I will just put all these notes in the Google Drive so that you can access. Okay. See, this was the first case. And we saw that if fx is greater than 1, so that's why it cannot belong to this. So precisely it is written given to here. And now if you take b is equal to 1 and choose epsilon equal to b is 1 means b is the limit. Let's assume x tends to 0, fx exists, and then let's assume it is b. Okay, so if it is b equal to let's say 1, and if you take epsilon is belongs to 0 to 1, then b minus epsilon to b plus epsilon, how it will be? So minus epsilon will be belongs to 0 to minus 1 because epsilon belongs to 0 to 1. So that implies b is 1, so b minus 1 will be 0 less than b minus epsilon is 1. So b minus epsilon will be greater than 0. and your b plus epsilon, okay, b plus epsilon will be yes, b plus epsilon will be 1 to 2. If I am not wrong, it will be 1 to 2. So mainly b minus epsilon is strictly greater than 0. That implies 0 does not belongs to b minus epsilon to b plus epsilon. So when 0 does not belongs to there, and you see fx is taking 0 values when x is less than equal to 0, right? So here also here it was x greater than 0, in this case it will be x less than 0, when x is less than 0 fx equal to 0. So any delta neighborhood will have this minus 0 to delta, at least this one, because it should have minus delta to delta whole thing. So that subset, this also should include in here, but all the any delta, for any delta minus delta to 0, this fx will be 0, and for all those x, fx does not belongs to b minus epsilon to b plus epsilon, so it cannot be the limit. So third case also similarly like this. So you'll just read it. Well, once you understand one first part, so you will understand all other things, right? So is it okay? Shall I move to the next question, or do you need more understanding on this? Okay, I'll assume that you will go through this and you understand this. Okay, because I'll suggest that you go through the second question. So instead of maybe first question, you go through once the second question. I hope you will understand better, much better, the epsilon delta definition. This is very good example I feel. So you just go through it once and you let me know whether you would understood better the epsilon delta definition. Okay, with all these things, I move to the third question, which says like find the continuity. See, I think interesting part of the lecture is gone mostly, the epsilon delta definition. I would say like most, and this will be very useful. Yeah, you have much more interesting, like you have many interesting questions, but the basic or base of the limit and continuity, which was epsilon delta definition, that is already done. Now we come to continuity. What's the meaning of that? Continuity is you had limit as x tends to, let's say c fx, you had that is as limit L. If L is equal to f of c, then we will say fx is continuous at the point C. Okay, that's all, and that's the continuity definition. You know limit, you know epsilon delta definition of limit. Also, you know that limit is nothing but fc. So whenever this fx minus fc, you have the epsilon, that will be whenever x minus c is less than delta. So nothing else. When you know limit, then you know the continuity is not a problem. So to remember that this L should be the point value there, f of c. Okay, now come to the find a value c such that fx is continuous at x equal to 1. As I said, if limit x tends to 1, fx is equal to f of c, then it will be done. Then it is continuous. Sorry, x tends to c, yes. So in this case, c is equal to 1. So limit as x tends to c, x tends to 1, fx should be f of 1. What is f of 1 here? Fx, the function taking minus 1 plus c when x is less than equal to 1. Right? Mean x equal to 1, it will be c minus 1. Minus 1 plus c, that is c minus 1. Now you have to evaluate what is x tends to 1 fx. Say that is c minus 1, it exists, so this should be equal to limit x tends to c minus f, sorry, not c minus, 1 minus fx. And that should be equal to also if limit x tends to 1 plus fx. So what is x tends to 1 minus fx? Limit x tends to 1 minus mean x is less than 1 and x is approaching to 1. And when x is less than equal to 1, this is minus x plus c, so minus 1 plus c. And what about this? When x tends to 1 plus, it will be 6 minus 2 times 1 square, 2, that is equal to 4. So mainly whatever you got, that is nothing but c minus 1 has to be equal to 4 for continuity. If it's not continued, then done. So that is not a problem. But for continuity, you need c minus 1 is equal to 4, so c is equal to 5. So only point is c is equal to 5. So at only c is equal to 5, the function is continuous. You have taken, if you take any other point, sorry, uh, for the c is, for this value c is equal to 5, you have this function is continuous at x equal to 1. You take any other point, sorry, any other value of c, fx will not be continuous. Okay, so this is, if people ask you give a family of function, like here is a f which depends on c mainly, fx c, you can write like this: c minus x when x is less than equal to 1, and otherwise, right, yeah, otherwise it will be 6 minus 2x square. So f only at 5 is continuous at x equal to 1, otherwise they are discontinuous at x equal to 1 for all f other than 5, fs which s is not 5. This is like people usually call the family of functions. Right? This family of function for c is equal to 5 only is continuous, but c is equal to c not equal to 5, it is discontinuous at x equal to 1. Okay, is it okay? This question 3. Hopefully it will be okay. So, much easier than whatever we have done. This it's not okay. Can you? I don't see messages. I can only hear. Okay, Advait says this okay. See, only he says okay means that does not imply everyone is okay. So all of you can tell. Okay, that whether it is okay or not, whether I should go through. Yeah, you can also tell whether, see, this answer is also done and written like this. So nicely written. You can check in, and also the important thing is you please let me know if it is there is any mistakes. Okay, there can be mistakes. Everyone, like, we are also learning, so it can be mistake, there can be mistakes, so you just do it by yourself and tell me if you find any mistake. See, this intermediate value theorem you have learned, so this is one application of intermediate value theorem. Very interesting question. Okay, fx is equal to x cube minus x minus 2, so that fx equal to 0 has a solution in the interval 1 to 2. How to do that? Let's say you know only intermediate value theorem. What is that intermediate value theorem? Once again, I will tell f is a continuous function from a, b to a real number, and if you have, let's say, fa less than, okay, fa and fb you have, and between that you have any number, any real number, let's say r, then you will find that there exists alpha such that f of alpha, I mean alpha will be of course in a to b such that f alpha is equal to r, f alpha is equal to 1. That is initial okay, ivp. Okay, that is ivt, intermediate value theory. Okay, so that is intermediate value, but using that, can you prove, can you say, can you prove this, can you show this, that f x equal to 0 is a solution in the interval, that is I'm fixing 1 to 2. Can you think for some time? Maybe 1 or 2 minutes I will maximum. Hello? See, fx equal to 0 has a solution, meaning what you need to find first of all, and can you tell me how to make sure this problems set up to this initial value problem. First of all, what you will see is fx, this function is continuous. See, all when you have polynomial type of function like this, they are usually, I mean, you have xn, you have xn minus 1, you just add by a constant, let's say cn minus 1, you have cn plus like that c naught. This is polynomial type of function, like of degree n, and this type of functions are always continuous. You can assume that. So when you have continuity, so function is continuous. That is not a problem, right? Now what else to do? Can you think here to here? So need to show that there exists alpha belongs to 1 to 2 such that f of alpha is equal to 0. Is not it? We'll go one by one. Okay, do you understand this? Why do we need to find this one? Okay, as Advait says that he solved it, can you please tell us what you did? Shall we discuss? Good. I think he did it. As he sent in the message box, you can, everyone can check also. Yeah, also see what we are doing it here. What is f of 1? F of 1 is 1 cube minus 1 minus 2, which is minus 2. What is f of 2? 2 cube minus 2 minus 2. 8 minus 4 is equal to 4. What can you see here from here? f1 is less than 0, less than f2, is not it? Because f1 is minus 2 and f2 is 4. So this is true. And f is continuous on 0 to, sorry, 1 to 2. On 1 to 2, f is continuous. So f is continuous, and if you have this, there should exist by initial, by intermediate value theorem, there should exist a alpha such that f alpha should be 0. It should take f alpha value. So whatever the intermediate values are there between 1 to 2, function takes all those values. If it was f1 to, it is, so you can ask that f1 is less than minus 3, sorry, not minus 3, minus 1 less than f2. Yeah, that is also true. So there will exist a beta such that f of beta is equal to minus 1. So what else you can say, that f beta is equal to minus 1 means x cube minus x minus 2, f, that is fx. So f beta is beta cube minus beta minus 2 should be also minus 1. That implies beta cube minus beta minus 1. So plus 1 will come here. So that will be minus 1 is equal to 0. So this, what else you can say, x cube minus x minus 1 also has a root beta. Right. So question was not this. I did up to this, but question's answer of the question was up to this. All of you can understand? Was it okay? Okay, so let's assume you have understood. Then there is a similar question. Please try to do it. Maybe maximum 1 or 2 minutes I'll wait. Then I'll do it. Then I'll go to next question. Okay, it was so quick from Advent. So tell me how you did that. So what is the meaning of this as a solution? Means fx is equal to x square. Let's consider fx equal to like this 2x plus 5. And you have to show that there exists alpha such that f alpha is equal to 4. Right? And for that you need to find two values of f such that 4 lies in there. So, right? So okay, so x square plus square root 2x plus 5. Right? 2x plus 5 is 0 when x is minus 2 by 5, right? How do you show that? There are values which are larger than 4, also less than 4. Okay, he is telling f0 is less than 4. What is f0? Let's everyone compute. F0 is square root of 5. Yeah, that is good. So f0 then is less than 4. Huh? And what else you have? You have to find f value which is greater than, let's say, f of 2, right? F of 2 will be 2 square plus square root of 2 times 2 plus 5. That is nothing but 4 plus square root of 9, that is 7. Yeah, we got a, so you have f0 to f2, and f from 0 to 2 to r, f from 0 to 2 to r is continuous. That is easy to see. And you have this continuity and plus this. So there will exist alpha, and okay, intermediate value theorem says that there should exist alpha such that f alpha is equal to 4. I mean, that's the solution. So you have a solution. Solution mean you can, there exists a x such that this happens. So f alpha is equal to 4 means fx is equal to x square. So alpha square plus square root of 2 alpha plus 5 is equal to 4. That implies square root of 2 alpha plus 5 is equal to 4 minus alpha square. So that means that 2x plus 5 is equal to 4 minus x square has a root, right? Yes. Is it okay? Okay, I'm hopeful that, yeah, this is okay. So solution is also given to you. Check it once. Now we move to the sixth question. Okay, is it interesting? This person is also interesting. So anyone try it here? See, I'm waiting because if you were trying, then you like, I don't want to spoil your hard work. Read it out maybe twice, thrice, and then try to find if you have any idea. Okay, let me do it. I think this time is getting over. So, anyone trying still wants some time, or if you have idea, also please share the idea. That is also good. So you have idea, then doing is still not a problem. If you have any idea, tell me. Advait, can you speak? Maybe no. I can't hear you, but I just saw your message. Yeah, that is a good idea, first of all. Because what you see from here, x2 will be 1 plus x1. Advait, I can hear you, but I saw your message, so that I can take it. X2 is x plus 1, 1 plus x1. So, mainly, there exist real numbers x1, x2, you don't need to find. So, what you need to find? One real number x1 such that x2 is 1 plus x1, right? So, x1, f of x1 should be 1 plus x1, right? If you can find that also, then it is not a problem, right? So once you find, see, once you find, if you find x1 such that f of x1 is equal to f of 1 plus x1, it happens, then what you will have, so you redefine, so x2 is equal to 1 plus x1, then what will happen, f of x1 is equal to f of x2 with x2 minus x1 is equal to 1, right? So that is not a problem. But how do you find x1 such that f of x1 is equal to 1, f of 1 plus x1? So you take the function gx is equal to f of 1 plus x minus fx, right? Like it says, he suggested. So mostly that is what I have written here. So then what you will see, what are the things given to you? F0 is equal to F2, F0 is equal to F2. So now let's see what is G0. What is Z0? Z0 will be F1 minus F0. What is G1? F2 minus F1. So now if you add these two, Z0 plus G1, what will be that? F2 minus F0. But it is given that F2 is equal to F0, so it will be 0. G0 and G1, G0 plus G1 will be 0. So what is the meaning of that? G0 is equal to negative of G1, right? So what is the meaning of that? So if G0 is greater than equal to 0, then G1 will be less than equal to 0, right? Less than equal to 0. Or if G0 is less than equal to 0, then G1 will be greater than equal to 0. So 0 will always lie between either G1 to G0 or G1 to G0, and G is a continuous function because f is continuous function, so G will be also continuous function. And you have like this, so what you can say that there exists alpha such that G alpha is equal to 0. And what is the meaning of G alpha is equal to 0? F of 1 plus alpha minus f of alpha equal to 0, that implies f of alpha. And now you take x1 is equal to alpha, x2 is equal to 1 plus alpha, then you will see f of x1 is equal to f of x2, and x1 minus x2, x2 minus x1 is equal to 1, right? That's what you wanted to prove. Is it okay? And wait, you want it like this? Yeah, great. I also saw your message. You wrote it. I did not see, but yeah, that's how you should do. Great. And answer is written here for all of you. Okay, I'll upload it. Is it okay now? I will keep it here maybe also, and you can once read it, and I'll just move after that. Okay, I think it's time to move, right? Let's move ahead. Okay, this is another interesting example. Try to find out if f is continuous, then you know, all of you know modulus of f is continuous. If you don't know also, let's remember f is continuous imply modulus f is continuous. It's very easy proof, huh? Because if you start with mod of f minus c for a positive number, let's say that will be less than equal to, I think, mod f minus c. And you know, whenever x minus c is less than delta, this is less than epsilon, so this one also will be less than epsilon. So whatever is that, the reason the f is continuous implies modulus f is continuous. But the converse is true, and converse is written here. Give an example of a function f such that f is discontinuous at each point, but modulus f is continuous. So even though modulus f is continuous on 0 to 1, f can be discontinuous at each point x belongs to 0 to 1. You can, one easy example you can give that will be discontinuous at one point and continuous at all other points. But here I want a function which is discontinuous at each point of x belongs to 0 to 1, but continuous on 0 to 1. Any idea for this one? So do you know any function which is continuous on discontinuous on 0 to 1 for all values? So if you don't know, I give you a function like this: 1 when x belongs to 0 1 Okay, I'll write it here. I mean, it was not like it is wrong. I'll have some more space to write. Fx is equal to 1 when x belongs to 0 1 intersection, let's say q complement, 0 when x belongs to 0 1 intersection q. Okay, so this function is discontinuous at each point of 0 to 1. That you can prove it. Okay, so this is a function. Okay, let's not, I mean, this function is discontinuous at each point in 0 to 1. Also in this instead of 0 I'll put minus 1. So even also that does not matter. Even if you take any two distinct number instead of 1 minus 1, even 2, 3, 4, 5, 1, 10, like that, any number, two distinct number you take, then it will be discontinuous at each point of 0 to, at each point in 0 to 1, right? So this function is f is discontinuous at each x belongs to 0 to 1. But what is modulus of f? Modulus of f is no matter whatever x, where does it belong, it will be 1. It's a constant function, right? So which is continuous at each x belongs to 0 to 1. Is it okay? Or any mistake here? So if I give you, like if I ask you, just find out function which is only discontinuous at one point, modulus of function is discontinuous at one point, sorry, function is discontinuous at one point, but modulus of function is continuous, that you can give me easily. The fx you take 1 when x is less than 0, minus 1 x is greater than 0. This is discontinuous at x equal to 0, but modulus of fx, that will be 1. This is continuous always. So at one point it is little easier, but for if you want for all point, you will have to go to these functions. This is that type function. Okay. Now come here. So different type. This is finding supremum infimum. I hope supremum infimum all of you know. Supremum is greatest, sorry, least upper bound, and infimum is greatest lower bound. So these are the options. Which option is correct? Tell me. What is supremum and infimum? Yes. How do you find that? So mainly you need to know how the function behaves. Okay. So you know when x is greater than 0, this function will be x over 1 plus x. And x is greater than 0, 1 x over 1 plus x will be always this one. Are you agree with me? So when x is greater than 0, like this. When x is less than 0, it will be minus 1 x to 1 plus x and greater than 0. So and this is continuous function on that interval minus 0 to like this. I mean, it on 0 to on r real number, it is continuous, and you will have all the points between minus 1 to 1. This function x over 1 plus mod x lies in minus 1 to 1. Also, you will see, you take any small number, so it will be mainly giving you minus 1 to 1 open interval, right? And when you have that, what is the supremum here? This, and infimum is this. So that is third option. So mainly you need to find the image of the function where it lies. So this A set is nothing but image of the function f, where f from R to R defined like f of x is equal to x over 1 plus mod x, right? So that's all we found, and we found minus 1 to 1 is the image, and because there's a continuity is there, everything is there, and that's why the infimum will be minus 1, supremum will be 1. Hopefully it was okay. So Advait says it was correct, and now I move to here. So any doubt here? Okay, any doubt here? Okay, no doubt. Let's move on then to next penultimate question. This is, and after that it will be last question. So this one will, you know what is the compact set in real number? Real number, in the real number, compact sets are nothing but closed and bounded. Compact in real number. Is this set is bounded? This set is bounded? Speak. Is it bounded? Okay, I have to check things. Advait, do you now understand what is the meaning of compact? I can't hear you. I can't just hear you. What is, if you are speaking also, you just send me message. No problem. Do you understand what is now compact? Compact means closed and bounded. Hopefully you know closed and boundedness. Please send message. I can't hear you.
Hear me now?
Yeah, I can hear you now.
I don't know what is meant by closed.
What is meaning by close? You know?
I don't know.
Okay. So is that will be okay. Is that not done in the class then? No.
I'm lagging behind a few lectures.
Okay. 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 That's see. You know about open set. What is open set? You know what is open set, right?
Where there are no endpoints.
No, 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 no. Open set is a set. If you have a point there, let's say S is open set of R. S is a subset of R. Then S will be called open set if for all A belongs to S, you have a delta such that A minus delta to A plus delta belongs to a subset of S. any for any point of that set should have a neighborhood which is entirely belong to that set. That's precisely the definition of the open set. Do you understand this? Let's say you have,
Yes.
yeah, you have, let's say A to B. Is it open set?
No,
Why?
because you can't find a neighborhood around A or B.
Good, very good. So that's all. You have, if you take A to B, that will be open because A and B are not included. And if you take any number between A to B, you can find a very small neighborhood. If you want, you can find a neighborhood that will be belongs to A to B, because you don't need all neighborhood. You need to find a neighborhood. So okay, now you understand what is open set, right?
Yes.
Okay, closed set is a set whose complement, complement,
Yes.
complement is open. That is, I mean, for now, this is also, this is a definition, but yeah, I should give much more rigorous for better understanding. But for now, if you take it this, you will learn later. Huh? Closed set is a set whose complement is open. That's all. And in the real number set of all real number, compact set are the set, compact set are nothing but closed and bounded sets. Which sets, if the set is closed and bounded, then it will be compact. Also, if the compact set, then it will be closed and bounded. Yeah. Now another definition of closed sets are there. Closed sets are in the by the definition of okay, using limit points. Do you know limit points? No? Then
No.
leave it. Okay, then leave it. Okay. Okay, then it will be a little difficult. That's why I think x is equal to 1 by n. Mainly, you are considering if you can show that, see, it is bounded. X is equal to 1 by n. N belongs to natural number. That is bounded. That is okay, right? Because x is
Yes.
subset of which, what is that? 0 to, sorry, 0 to 1. I mean, it can maximum take one value, or it can means it will vary from 0 to 1. It's a bounded set, right? That is okay. Now need to prove that r minus 1 by n is open. Is open. So as you don't know the limit point definition, so you need to prove that this one is open. R minus 1 by n is open. So that you can easily prove, I think, right? So take any point. These are the points you are excluding. R minus 1 by n, you are excluding points. So that is nothing but, like, you have whole real number, then you are excluding half, 1 by 3, 1 by 4. You have a distance and you are 1 by 5, like that. These are the number you are excluding. So whatever number you take, you find a small neighborhood. Let's say you take in between this. So, and 1 is here. If you have a point here, then you have a neighborhood, no problem. That will be belongs to r minus 1 by n, right? We want, if r minus 1 by n is okay, sorry. Yeah, okay, yeah, I understand. So what do you need to prove that r minus 1 by n is not open, right? It is, if it's not open, then r minus 1 by n also, sorry, 1 by n will be open. So that is my claim, actually. My claim is that. So now r minus 1 by has, let's say 0 is a neighborhood, right? 0 is a point which belongs to r minus 1 by n. Right? Correct? Now take
Yes.
any neighborhood minus delta to delta, which is a neighborhood of 0. Can you say that that will be belongs to r minus 1 by n? No matter what delta you choose, whatever small, you will find, because delta is greater than 0, you will find the n such that n delta is greater than 1, right? So delta will be, sorry, in delta greater than, in delta is less than 1. So you can find also delta is greater than 0 and 1 you have. So yeah, 1 by delta is also then greater than 0. So you can find 1 by n, right? 1 by n which is less than delta, right? Intermediate value theorem says that n times delta should be greater than 1. So 1 by n, so there exists a n. So let's say capital N, let's say that is capital N. 1 by n is less than delta. So what you can find is that minus delta to delta cannot be subset of r minus 1 by n for all n because it has 1 by capital N. Do you understand this little bit?
Yes.
Right? Okay. So if you understand this, then what happens? What we got it? R minus 1 by n is not open. Right? So 1 by n actually not closed. So it's not closed, so it not compact. That's all. Although it is bounded, it's not compact because it's not closed. Was it okay? Do you understand?
Yes.
Yeah. So now tell the
Yes.
last question and then we'll complete this, finish the class. Last question is question 10. Although I mean this is the question, okay? This have to mainly I'll write it here maybe x to the power 4 such that minus 1 x less than 1. This is a set. So mainly this A set is, you think like this, image of a function g where gx is equal to x to the power 4 and g defined on minus 1 to 1 to real number, right? What will be that in the image of g?
Close 0 to open 1.
Sorry, 0 to
0 to 1.
like this.
No. 0 closed.
Great, because x, when x is 0 then it will be x to the power 4 will be 0, so that is there, that is included. But when x is plus minus 1, but that is x plus minus 1 is not included in the domain, so x to the power 4 will be 1, but x to the power will not take 1 because this x to the 4 will be 1 only when x is plus minus 1, right? Otherwise for in no real numbers are there for which it will be plus minus 1. Oh, sorry, it will be 1, x to the 4 will be 1. So it will be mainly from 0 to 1 and it's continuous also. It takes from 0 to 1 value, okay? So due to this, image of Z means A will be nothing but this type of. So whether this set is closed or open, can anyone tell?
This is closed.
This is closed.
Means you
How?
cannot find a neighborhood around 0.
You cannot find any neighborhood around 0. So it's not open.
Yes.
That you are correct. It is not open, but you cannot say it is not closed, right? You cannot say it is not closed. Not open does not imply not closed. It can happen that neither closed nor open. Because what is the closed definition? I said closed mean a complement should be open. A complement is what? Minus infinity to
Minus infinity to 0.
union 1 to infinity, right? 1 is here
Yes.
closed, and so a complement is what? A complement cannot
It's
be
not open.
not open, not open. So a is not closed. So this is one set which is neither open nor closed. Do you understand this?
Yes.
Okay, so it was a great session, I think. I mean, for from my side, I don't know about your side. See, this is the answer I have given. I'll upload all these things. And if you have any doubt, please tell. I'll wait for 1 or 2 minutes, then I'll end the session. Okay.
Yes. Sir, can you please summarize what was taught from the start because I joined late?
Sorry?
Can you please briefly summarize what was taught from the start because I joined late?
Okay. Yeah, that is only one question, I think. You came when you came, it was, if you remember correctly, this is the thing, right? This limit I was
Yes.
calculating. Is not it? Or not this?
Yes, this was the
Then before that only one question I did, right? So this is the question. This is the first question. Even you came from second question. So first question what we started with is 1 by x, the limit should be 1 by c. Hmm? So epsilon delta definition, we try to find out what is the c. For we want to show that for all epsilon, there is delta such that this. So we start computing this 1 by x minus 1 by c, which will be like this. Now we choose in such a way that so delta 1 c by 2, and then what will happen, cx will be greater than c squared by 2, and you can get this type of inequality. And you choose delta 2 like this and delta like minimum of this, then you can show that whenever this one happens, this one is true, where delta depends on c and epsilon. So you once go through this. If not, I will tell you. Hmm?
Yes, I will go through this.
It's okay, right? I mean, otherwise I can tell you. No problem. In the next class, I'll tell you. And also, video is there. You can just check it once, maybe. Not only for this question.
Yes.
Right? Is it okay from your side? I mean, it's okay because whatever you
Yes, it's
understood
okay.
from x epsilon delta epsilon, those were much harder than this. So if you understand those things, this will be very easy for you. Hmm? And answer is also given. I
Yes.
will share. Okay. Okay then. Thank you for your attention. Any question? Okay. Before that, any question? Any other?
No, sir.
Okay. Then see you on the next class.
Yes, sir. Thank you, sir.
Thank you for your attention. Hmm.